Hello everyone, in today's video we are going to see how to set up a bare metal Kubernetes cluster with one control plane and n number of worker nodes. And the way we'll be doing this is we'll be using Fedora 41 server edition, and we'll be making use of VirtualBox to make multiple virtual machines and make cluster out of them. So first things first, I want you to do is get Fedora 41 server edition ISO image and boot it into it, install it, and run DNF update in it. If you are in non-root user, then do sudo DNF update. Once you have done that, keep this as Fedora 41 server base image. From this, make clones. Now before making clone, I want you to ensure that you have provided two processors to it, 2 GB of base memory, and in settings head to network and make sure it's attached to bridge adapter rather than NAT. Once you have ensured all these settings, go ahead and clone this machine, give them distinct names, YTK8's control plane. Make sure to generate new MAC addresses. This is very essential step because in Kubernetes cluster, MAC address is very important, and if you keep all the MAC addresses same, then you're gonna face issues while making the cluster. So I'm gonna clone this 3 times. Alright, once you have cloned this, make sure to headless start these. The reason we need to do headless start, you are gonna see in just a second. So when I click on show over here, all I need to see once the machine is done booting is the IP address that it was assigned. That's it. So over here we can see IP address of 213 for the control plane, and we are just gonna go continue running in background, and we can see the next machine 214 for worker 1, and I'm gonna assume 215 for worker 2, but 215. So once you have identified the IPs, I want you to go ahead and see if you have terminator with you. The reason being these windows you're gonna see just in a second, but yeah, let's go ahead and SSH into what I want you to do is turn on broadcast all SSH root @192.168.2.21, and then it's gonna vary for all the machines. Broadcast off. Let's just go ahead and ensure if it's still 213. So let's go back to terminator 213, enter, yes, and let's 214, yes, finally 215, yes, and the password. Great. So there are few things that we need to do. First thing you might have noticed is localhost, localhost, localhost. All 3 machines have same name, the same username as well. So it would be very confusing for us. So what we need to do is do host name ctl set host name, and we are going to keep different host name for all the machines. So CP over here, worker 1 over here, and finally worker 2 over here. Alright, now you might notice that Gaurav, the host name is not being reflected. It will get reflected when we reboot these systems. So before we reboot it, we need to do a few steps. So we need to disable swap. This is the command to do so. if you see over here, fail to stop unit not loaded, but still this is on the safer side, we are doing so. And also what we need to do is make our IP static. Kubernetes cluster doesn't operate on dynamic IP, though at least the one that we are gonna create. So what you need to do is run nmcli const show. You'll get UUID over here. Now from the Medium article that I'll be attaching the link to in the description, go ahead and I want you to copy this, all right, and paste it in a text editor. All right, then copy this, select UUID name, Control H, replace over here, enter this UUID and replace all. And there we go. Just make sure this IP, this number is the same as your router. So open your normal terminal and over here do ifconfig and see what is the number for your router. So it's 2 for me. So I'm gonna keep all these things same, 2.120, 2.1. So let's copy this, go back to Terminator and paste it. And obviously IPs are gonna be different for all of them. So let's turn off broadcast and enter over here. Over here we update it to 21 and enter, and finally 22 and enter. Now what happened right here is we have set up a static IP for our machines, so we won't be able to connect to them now, at least not from this session. So what we need to do is close the terminals. We need to open Terminator again. And in this, we again start broadcast, Control R, SSH, and we just change this final number for all of them. So over here we have 120, over here 121, and over here 122. Again, I want you to turn on broadcast. Let's enter. And there you see, control plane, worker 1, worker 2. And that's that. But if we do free-h, we can see there is a swap of 2 GB. So to ensure that the swap is disabled properly, we need to do reboot now. And that will disconnect us and give it some time, a minute or two, to restart. And once it's done restarting, just SSH right back, and there we go. Now if we do free-h, you can see the swap is 0 in all 3 machines. All right, perfect. So far we are achieving the prerequisites. We have currently set up a static IP address and we have turned off the swap. Now what we need to go ahead and do is install the necessary things. But before that, just for this training environment, I want you to go ahead and systemctl disable now firewall D. Now please note that we are going to do this just in this training environment where we are setting up the cluster, getting to know Kubernetes. But in production environment, make sure to implement the proper firewall rules instead of simply just disabling it. Going ahead, we are gonna DNF install IP tables and IP route TC. The reason we are doing it, these are the network utilities required for Kubernetes. Once it's done, we are gonna load a few kernel modules. And you get why we are using Terminator now, because we get the starting initial setup for all the machines is the same. So instead of typing it out in all three machines separately, we simply type it once in single machine. Anyways, we are going to load kernel modules now. These modules enable overlay networks and bridge network filtering required for container networking. Next up, we configure kernel parameters, and over here you can see we had set up IP forward equals to 1, and over here when we do systemctl system, we can see that IP forwarding is enabled. So what does these settings do exactly? So what we do over here is these settings enable IP forwarding and bridge network call settings required for Kubernetes networking. All right. So yeah, let's go ahead and get into the Kubernetes part itself now. DNF install -yes container networking plugins, right? Then kubelet, then kubeadm, and finally kubectl. Now what are these things? So the very first, the container networking plugins. It provides CNI plugins for pod networking. Kubelet is the primary node agent. It exists on all node. kubeadm is tool for bootstrapping the cluster, and kubectl is like command line tool for interacting with the cluster. Now note that for setup purposes we are gonna need kubeadm and kubectl, and kubelet is going to run on all the nodes anyways, so that's that. But yeah, let's give it some time and let things get installed properly on all three machines. Once everything has been successfully installed, we need to go ahead and enable kubelet. So the command is systemctl enable -now kubelet. Next, we need to do systemctl start container d. So for container runtime interface, we are going to be using container d. And once we have started it, to make sure it starts on every reboot, we do systemctl enable container d. Now we need to configure container d. So before that, let's copy the default config files for container d. Once that's done, we simply do vi and copy paste this. And over here we need to do /system c group. My bad. Systemd c group. Enter. Over here we need to turn this into true. Escape wq, and that will write it. Finally, we do systemctl restart container d. Now, why did we exactly enable systemd c group? It is required like for proper resource management by the containerd in Kubernetes. So that's that. Let's go ahead and check the status of containerd, see if it's working. It's active in all three. So exit, Control C, Control L, clear the terminal. Now the setup gets, this was so far the setup was for all three nodes. Now it's going to vary. So let's turn on broadcast, turn off broadcast. What I want you to run in control plane is kubeadm init pod network CIDR equals to 10.244.0.0/16. Make sure to enter it correctly, properly, because this is used by Flannel, which is a CNI. What we saw before, container D is CRI, container runtime interface. CNI is container networking interface. I've also included a diagram if you scroll a bit down below. But yeah, this will take a bit of time. So let's fast forward. All right. Once the setup is done, you are gonna see bunch of things over here. Make sure to read it. So the first things first, your Kubernetes control plane has initialized successfully. Congratulations. This was the major hurdle you could have faced. Now below it you will see, to start using your cluster you need to run the following as a regular user. Now in my system I don't have any regular user, so I'm gonna simply run it as is. So what does these commands do? It basically puts the kubeconfig file, and yeah, it sets up the local kubectl configuration for cluster management so that you can access the cluster using kubectl. Now for you root user, we could have simply done just this, but since we have already ran it, we don't need to do anything again. But yeah, on the safer side, let's run it. Why not? Now you should deploy a pod network to the cluster. Over here you can see run kubectl apply-f pod network.yaml with one of the options listed to this add-ons. So you can check it out, see which pod network is the best, the suitable one you think for you, and you can read over here. Then you can join any number of worker nodes by running the following on each as root. So make sure to just copy this command and save it to your text editor or somewhere. I'm going to save it in text editor itself, and yeah, let's go ahead. So if we do kubectl get po -a, you're going to see code DNS is pending, and the reason this is pending is we don't have a pod network. Yeah, we don't have any CNI in our cluster, that's why it's pending. So we are going to use Flannel, and you can copy the command from the medium blog kubectl apply-f this. Now enter. Now you're gonna see that it's still going to show pending and it's going to be in init state. So let's do watch this. So kube Flannel is running, and once it's running, you'll see kube system code DNS is in container creating mode. Give it a bit of time. And still in container creating mode. So if nothing seems to be working, what you should do is kubectl events when the pod itself is being created. That time the logs are not being generated, right? So do po / the pod name -n kube system. So over here you can see failed to find plugin loopback in path kubelet/opt/cni/bin. So this is the error that you're going to face in all of them. So for this, what you need to do is run the curl command that I have put right below this. And once you run the curl command, you will see that your pods will start running again. So that's one plugin that's missing. So using that curl command, we add the plugins to the path, and yeah, as you can see, all of them are running, meaning your control plane is set up and as well as your CNI has been set up. So now the next thing that you need to do is take this command and paste it over here, paste it over here as well. As you can see, it's kubectl get no. It's going to show worker 1, worker 2 not ready. And why is that? So if we do again get PO all, we are again gonna see Flannel is in init mode. So give it a bit of time and it's running again. And now if we do kubectl get no, you can see control plane is ready and both of our workers are ready as well. And just a final good step that we can do is kubectl label node and the node name. Over here the node is worker 1. All right, and the role ahead of that is going to be this that you can get from the blog. Basically we are labeling the node as worker so that when we deploy our applications, the correct roles, the only worker can schedule pods on it, the application related pods. It won't get scheduled on control plane because it has that taint. You can think of it this way: control plane is the brain of your cluster and workers are the actual brawl of your cluster. So they do all the work, but coordinating them is the role of control plane. So over here you can see worker 1 has the role of worker. Let's go ahead and do the same for worker 2 as well. And that's it. If we do kubectl get nodes, we have control plane worker 1, worker 2 ready, and roles as well as the roles are correct. Next up we can do kubectl get pods -a to show all pods, and we can see all of them are running as well. And yeah, if you see the steps, then your cluster was set up correctly. Now just a bonus step you might consider, instead of having to type kubectl all the time, right, what we can do is alias k equals to kubectl, but this is not persistent. Now if we do k, it will run kubectl in the background, but this is not persistent. If I go in new tab, let me just SSH again. And if I try to type k over here, it will say command not found. So to make it persistent, what we need to do is nano tilt /dot-bash rc. Okay, nano is not there, my bad. vi, and I want you to go all the way down, go in insert mode and alias k equals to kubectl. All right, escape, right q, enter, and now to apply the changes we do source tilt bash rc. There we go. The changes have been applied. If I go to this tab now and type K, let me just make a new tab. SSH 120. And now if I type K over here, you can see it's working. So yeah, that's that. And you have your cluster setup. Congratulations. You can do now K get no, and you can see again for the third times the charm, the cluster is set up. The version is 1.32.5. And what next? We are done with all the steps. Make sure to go through those diagrams as well. And now security considerations. In production, as I mentioned before as well, configure firewall rules properly. Use secure communication between nodes. Implement role-based access management and network policies. Patch the systems regularly and use encrypted channels and secure secrets. Next up, for troubleshooting, if you face any troubles, pod is stuck in pending, check the CNI status first, check the node condition, view the kubectl logs. Else, I also showed you the kubectl events one. So run that command. For worker node join failure, check if the validate the token that was that you are using. Also check if the network is reachable, if the host machines, if the control plane is reachable from the worker node or not. You can use ping command for the same. And also finally check for certificate distribution. So now you are done with all setup. You have correctly set up your Kubernetes cluster. What's the next step? Deploy a sample app. Once you have done that, go ahead and set up a persistent volume. Next up, go ahead and implement monitoring. A good example of that would be Prometheus. Next up, once you have implemented monitoring, let's move on to some harder things. Go ahead and add logging to it. EFK stack is the most popular. ELK stack is a good one as well. Finally, plan backup and recovery as well. And finally, configure horizontal high availability and load balancing. And once you have done that, you have a pretty good grasp of the basics related to Kubernetes. So kudos. That was Kubernetes cluster in 30 minutes. Thanks for watching, and I hope to see you in the next one.